Okay, so given that y equals x squared plus 10x, find dy dx from first principles, okay? So when they say first principles, and it's worth about 5 marks, okay? It's going to take a bit of time to get this answer out. Of course, when we differentiate this, we know it's 2x plus 10, okay? But they want it from first principles, right? They want us to actually prove why it's 2x plus 10. And the way I do that is I draw a little curve, right, here, and I pick 2 points on the curve, right? So P and Q, just a sketch, P and Q. And my point P represents a general point on this curve, okay? Just a general point. Any point, general point, where the x value I'm just going to call x, okay? And of course, if my x value is x, well, my y value then is going to be from here, isn't it? My y value is literally going to be x squared plus 10x, okay? So that would be my coordinate at P, okay? Of course, whatever x is, okay, if it's a certain value, I can then work out what y is by subbing it in here. But that is my coordinate at P. What I do then is I go a little bit along the curve, right? In fact, a horizontal distance of h. Okay, so go from P, a horizontal distance of h, to another point Q on the curve. Okay, now the coordinate of that I can define quite clearly, because if you think about it, it's a distance of h to the right from point P. So what's happened to the x value there? Let's have a think about what's happened to it. Well, if I've gone to the right, if I've gone this way, I've made it bigger, haven't I? Made it bigger, and of course, because I've gone a distance h, I just need to add h onto x, all right? So I don't know what x is, I don't know what h is, they represent values, right? But essentially, that's what my x value would be, wouldn't it, at q, because I'm a distance to the right of p, so you just need to add on that distance h onto x. So that's what it'll be, right? That'll be my x value there at q. Of course, if that's my x value at q, I can work out what my y value is, and I'd need to substitute this in, wouldn't I? I'd need to substitute this into here. So I'd have x plus h all squared. Okay, so I put that x value in here, not forgetting I've got to square it. So that's why I got a bracket squared. And then it says plus 10x. Of course, then I put my x value in there, and there's a 10 in front of it. So I'll have a bracket, okay, and 10x plus h. Then close that coordinate. So quite a large coordinate there, isn't it? And in order to get dy dx, what I'm going to first of all consider is this chord here. Okay, I'm going to work out the gradient of this chord that's joining P to Q. Okay, that's why I've drawn this here. Of course, the curve is what I'm interested in. I'm interested in the gradient and dy dx of the curve. But if I draw the chord there from P to Q, I can now focus on that chord and work out the gradient of it. And the gradient is easy, because if I've got a straight line, to get the gradient of a straight line, don't forget, I need to do y2 over minus y1 over x2 minus x1. In other words, the difference in y's divided by the difference in x's. The vertical change divided by the horizontal change. Okay, the rise divided by the step. And in this case then, it's going to be quite long, right? Because if you think about it now, these will represent here the coordinates that I've got for P and Q. Okay, so this might be my, let's call this my x2, y2. Okay, and then this will be my x1, y1. That would make sense. Okay, call these your x2, y2 because it's further along to the right. So now, if I got to do y2, okay, it's all of this, isn't it? All of this we need to write out. So x plus h all squared plus 10 bracket x plus h. Take away my y1. And my y1 is this, okay, my y value. So I've got to take away all of this. So maybe put in a bracket to show I've got to take it all away. Okay, and then that's all over x2, take away x1. My x2, of course, is x plus h. And I need to take away my x1, which is just x. So I can do a bit of simplifying now. In this case here, x plus h bracket all squared. Well, I need to write that bracket out twice because it's bracket squared, isn't it? Times by itself. This bracket here I can expand, just times by 10. So 10 times x is 10x. And then 10 times h is 10h. Be careful here, because you know we've taken away the y1. We need to have that minus applied to each term. So minus the x squared, and then minus the 10x. Okay? And what's good then on the bottom, if you notice, always happens, those x's will cancel, won't they? That x and minus x will become 0. So you're just left with h on the bottom. The other thing as well now on the top, you'll notice 10x there cancels with a minus 10x. And what we'll do then is we'll expand this bracket here. So we get x squared when you do the firsts. The outers will be xh. The inners will be hx. Okay, or I can write it xh again. The lasts will be h squared. That becomes plus 10h minus x squared all over h. What I'd like you to see then is, look, there's an x squared here, that cancels with a minus x squared. Okay, so that's nice, that goes. And then on the top, we get 2xh, so xh and xh is 2xh, plus h squared plus 10h over h. Now what you notice now is, I hope you can see that h is a common factor of each of these terms. H goes into all of them. So I could actually factorize out a h. So I could say, look, h here, take it out, bracket. What do I times by h to get 2xh? Well, that'll be 2x. What do I times by h to get h squared? Well, that'll be h. And what do I times by h to get 10h? That'll be 10. All over h. So h is cancelled, so I get 2x plus h plus 10. And remember, that is the gradient of PQ. Yeah? So the gradient of PQ is 2x plus h plus 10. But what I want, of course, is dy by dx. And what you've got to remember is to get dy by dx, right, quite simply, is what happens when you let h go to 0. Because as you reduce the value of h, as you reduce this distance, q gets closer and closer to p. I can start drawing in different q points. So reducing h would bring it closer. The gap would be closer, so you could have q there. Reduce it again, even closer. Reduce it again, even closer. And as it gets closer and closer, it essentially becomes the tangent at p, right, as you let h go to 0. So what we say is, look, dy dx is the limit. Got to write this in, you've got to write those in, limit as h goes to 0. So what we're doing is, essentially, we are limiting h, aren't we? We are limiting it to 0, and if that becomes 0, you get 2x. Of course, that goes plus 10, which is exactly what we wanted. X squared plus 10x becomes 2x plus 10.